High-voltage substations are an integral part of the power grid, each station distributing power to thousands of commercial and residential customers. Substations are equipped with sophisticated monitoring and metering capabilities, safety features, and redundancies, and require a high level of expertise to operate and maintain. One of the principal functions of substations is to transform, or step down, high-voltage power to lower magnitudes for distribution to customers. When the high-voltage transmission line reaches the substation, the power passes through a disconnect switch. This switch serves as a disconnect point should the line need to be isolated from station equipment. Devices known as instrument transformers are connected to substation equipment to monitor the power flowing through it. Instrument transformers are high-accuracy electrical devices used to safely isolate and convert the dangerous energy levels in the station to levels that can be used by metering and protective relay systems. They can also be the point where a carrier signal is introduced into the transmission line. Most substations are part of a larger grid or network of stations. Power line carrier systems provide a means for protective relays at two connected substations to communicate with each other via the transmission line between them. This allows the protection systems to isolate a fault more reliably and quickly. Next, the current passes through circuit breakers. Circuit breakers are used to interrupt a circuit under normal conditions or under fault or emergency conditions. Circuit breakers house an interruption chamber containing oil or sulfur hexafluoride as the dielectric medium in which the interruption takes place. In some cases, high-pressure air is used to interrupt circuits. Next are the transmission class buses. These buses are the interconnection points in substations where transmission lines, transformers, capacitor banks, and circuit breakers are electrically tied together. Sometimes capacitors are attached to the buses through additional switches. Capacitor banks lower reactive power losses by counteracting inductive reactance produced by motors and transmission line characteristics. Power next goes to power transformers, where the voltage is transformed or stepped down to a lower magnitude for distribution to customers. Manufacturers affix nameplates to transformers in order to provide a permanent record of vital information about the transformer, such as cooling class, MVA rating, voltage rating, internal CT ratios, winding type such as delta or Y, and cooling system details. Power transformers are cooled in stages depending on their internal temperature. They can be cooled by natural convection, forced air, or oil, or a combination of these. Lightning arresters are protective devices that help prevent damage to equipment by limiting surge voltages primarily due to lightning strikes. After being stepped down by the power transformer, the power passes through additional switches and breakers to reach the distribution class buses, where it is routed to additional instrument transformers and to station service transformers, which tap directly from the distribution bus and provide low-voltage power for substation controls. Power finally passes through distribution breakers, and sometimes voltage regulators, on its way out of the substation towards the various customers. Regulators are sometimes used on distribution circuits to help maintain a stable voltage as loading changes. Some power transformers can contain a regulator that can automatically stabilize the voltage of the entire bus. The operation of protective relays, circuit breakers, and other control circuits in a substation is powered by a direct current control system. It operates independently of the AC system to allow for continued functionality in the event of an AC power interruption. It allows for reliable isolation of faulted equipment, minimizing the disturbance to the on-site and interconnected utilities. SCADA systems are also located in the control house. These systems allow operators at a centralized location to see the real-time status of the entire grid. The DC system is powered by a battery bank, which is continually recharged by the AC system. The DC controls powered by the bank can typically function for several hours if the AC supply is interrupted. The DC distribution panel performs the same function as the breaker panel in your house. It separates the DC supply into many circuits that feed the various protective, control, and monitoring systems in the station. A ground detector alerts personnel to the presence of a ground on the DC system from various causes, such as damaged wires or water infiltration. Unlike AC circuits, the DC system is not designed to be grounded. Protective relays, or relays for short, are electrical devices that monitor the power systems and decide when protective action should be taken. These relays generally open, or trip, one or more circuit breakers, or initiate alarms. Substations are complex systems for managing and distributing large amounts of electrical energy, with numerous safeguards that help reduce the impact incidents might have on the grid as a whole. These features are not primarily there to protect personnel, but to reduce the possible damage caused to equipment. People are their own best defense against bad things happening to them.